Let's ask this question. If the frequency of a wave changes, what else must change? Must change. Let's try looking at wave A, the second one B. There's wave A. What have I changed? That's much higher frequency, isn't it? Sure. That's a high frequency wave, that's low, okay? Now look at that picture. If you look carefully and think just a moment, you should see something else that changed. Can you see it? It's wavelength. Here, this wave goes up and down fairly slowly, so the waves are kind of spaced out, longer wavelength. Here, up and down pretty quick. They're crunched together, aren't they, the waves? A smaller wavelength. Right, so uh, whenever frequency changes, wavelength must change. Always, there's no exceptions to this. So here's an example. If frequency increases, and we did increase it, wavelength decreases. Smaller wavelength. Remember we said a while ago in a video, uh, uh, frequency and wavelength are inversely proportional. This just sounds crazy, kind of tough, doesn't it? It's not. It just means if one increases, the other decreases. And that's true here, isn't it? So, we have, wait a minute. Does this work for longitudinal waves also? Let's see. Here's A. What are we changing to B? Didn't we go high frequency to low frequency? Yes, from A to B, frequency obviously declined. Fewer waves here and more waves here. Did wavelength go in the opposite direction also? So if frequency from here to here declined, wavelength should get bigger, shouldn't it? Is that true? Yup. Frequency increased. Look at that wavelength. Frequency decreased, and wavelength got bigger, didn't it? Yep. Again, wavelength must change if frequency changes, and it's in the opposite direction, isn't it? They're inversely proportional. If one increases, the other decreases. See, does changing frequency change amplitude? Look at these two guys. Frequency definitely changing here, higher here, lower here, right? But are these waves any taller, either of them, or they're the same height? They're the same height. Amplitude goes from the center line, so I've drawn that here, and there's amplitude on the high frequency wave, and there it is on the low frequency wave. So, how about amplitude? Did it change when frequency changed? No, it's the same height. Must amplitude change when frequency changes? No. Wavelength must change. So before, amplitude does not have to change. It's not affected by frequency. Last thing we're going to look at here is ask this question here. Does a change in frequency change wave velocity? The velocity at which the wave moves forward here. Does it? Well, the answer is no, it does not. If you make this thing go up and down faster, it will still go forward at the same velocity. A higher frequency wave does not travel forward faster than a low frequency wave. But, look at this. A high frequency wave, this one here, does travel faster in some direction. Not forward. What's that direction? It's actually two directions, up and down. This one here is going up and down a lot faster than that one, isn't it? It does not move faster forward, but here, a lot faster up and down, doesn't it? A good example of velocity, frequency not affecting wave velocity are these two singers. Turns out in air, all sounds travel at the same velocity. It's called the speed of sound. You've heard of it, right? This gal sings a high frequency, 343 meters per second, speed of sound. This guy down here is lower, same speed of sound. Yep, the frequency does not change the velocity at which these sound waves move forward. Another great example is your EM spectrum. Remember that? It says here, all EM waves travel at the same velocity, and they do. It's called the speed of light. All these travel at that thing called the speed of light. Even though the radio is not light, we still use that term. These sluggish up and down radio waves go at the same velocity as these incredibly fast up and down gammas. It's the same velocity, even though their frequencies vary wildly. Very different frequencies, but they all travel at the same speed. So this will summarize. If we change frequency, look at these three quantities. If frequency changes, does wavelength change? Yes, always. It must change, always. When frequency changes, does amplitude have to change? Nope, it does not. Not affected. And how about wave velocity going forward? Nope. Frequency does not change that velocity. Really, it's only wavelength that has to change. And it always changes when you change frequency. Bye.